In the last two videos, we discussed about the graph representation methods. They are adjacency matrix representation of graph, also called as sequential representation of graph, and adjacency list representation of graph, which is also called as linked list representation. And in this video, we will discuss about the BFS and DFS algorithm, where BFS is breadth first search and DFS is depth first search. These are two graph traversal methods. So first we will discuss about the BFS. BFS is nothing but the breadth first search, also called as level order search. This is the example of the graph I will be using here to understand the BFS traversal. In BFS traversal, you can start traversing graph from any node. So the root node can be any of the node in the graph. Sometimes you can get a question where it is specifically mentioned that traverse the graph taking particular node. Say for example B as a root node. Then you should traverse the graph from B. Here nothing is mentioned particularly. So we will start with the node A. I am taking A as a root node. In BFS we use queue data structure. I hope you remember the queue data structure. If not, please watch the queue related video posted in the same series. DSA full course playlist link is given in the description below. And we know that the queue works on FIFO principle, that is first in first out principle. Here I am taking the queue and we will store the result here. Our root node is A, so we will begin the traversing from A. The nodes adjacent to A will be traversed first. As I have taken A as a root node, A will be inserted first in the queue and will delete it from the queue and print in the result. Once it is deleted, it will be printed in the result and marked as a visited here in the graph. Next, the adjacent nodes to A are B, D and E. So I will insert them next. B, D, E. It is not necessary to insert in the same order. You can insert the way you want. E, D, B or D, E, B, anything you want. Next node is B, so delete B and store the value in result. Mark as visited. Now check the adjacent vertices of B. Adjacent and unvisited vertices of B will be inserted further in the queue. So the adjacent vertices of B are A, C, E, F. But A is already visited. So insert next node C, and E is already inserted. So insert next node F. Next vertex is D. So now we will delete D and store it in the result and mark it as visited. The nodes that are adjacent to D are A and E. A is already visited and E is already inserted. So we will move to the next vertex, that is E. This process of finding the adjacent nodes of the vertices is called exploration of node. Delete E and print the result and mark it as visited. Now we will explore vertex E. Adjacent nodes of E are A, B, D and F. AD and B are already visited and F is inserted in the queue. So move to the next vertex, that is C. Delete it, print the result, mark it as a visited. Adjacent nodes to C are B, F, G. B is visited, F is inserted. Now remaining G will be inserted in the queue. Next delete F, print the result, mark it as visited. Adjacent nodes to F are B, C, E, G, where B, C, E are already visited and G is inserted. So delete G and print the result and mark it as visited. So this is the BFS traversal of the graph. This is not only the BFS of this graph. Well, there can be numerous BFS of this graph because I have taken root node as A. You can take any other node and the sequence of inserting the nodes in the queue can differ. So we can get numerous BFS of this graph. Next, we will discuss about the DFS. Please like the video, subscribe to our channel and please hit on bell icon to get notified whenever we post new videos. Install DSA application from the Google Play Store or from the link given in the description below. Please let us know if you have any queries in the comment section below. And thank you for watching.